Welcome back to my YouTube channel. Today I'll be presenting the term paper of my house price predictor model. I had to change the project from house and land price predictor model to just house price predictor model due to lack of availability of a data set information on that has information and features that contribute towards land prices. So let's start the contents of this presentation: the introduction, background and motivation, literature review, methodology, results and discussion, and the conclusion and features. The introduction. The main keywords in this introduction will be artificial intelligence, machine learning, real estate, and feature engineering. In my past videos, I have explained the reason why I wanted to build this house price predictor model, and it's also in the term paper. So, on these keywords, artificial intelligence, this is a rapidly growing field that has gained immense popularity in the recent years due to its potential to revolutionize various industries. Now, AI can perform complex tasks with a high degree of accuracy and efficiency, making it a valuable tool for solving real-world problems like fairly giving prices of real estate. Machine learning, this is a subfield of AI concerned with the development of algorithms that allow computers to learn data and make predictions or decisions. In this project, I'll be using machine learning techniques to develop a model that can predict house prices based on historical data. Real estate, this is basically the market for buying, selling, and renting properties. Understanding how this market works and the features that influence house prices is crucial for developing an effective house price predictor. It's also crucial in choosing the dataset. Feature engineering. This is a process of selecting and transforming the variables or features that the machine learning model will use as its inputs. It can involve transforming raw data into a more useful format or creating new variables based on existing data, and also only selecting the most relevant variables to use in this model. This is demonstrated in the final source code notebook. The background and motivation. The motivation for this project is to demonstrate the potential of AI in house price prediction and also to provide a solution that can help buyers and sellers make informed decisions. This project will provide more valuable insights into the housing market and contribute to the development of more advanced predictive models in the future. This project is just a beginning. Literature review. The use of machine learning for house price prediction has received significant attention in the previous years, and a growing number of stakeholders seek to use AI to make informed decisions about buying and selling homes, also to reduce the bias in this real estate industry. We shall focus on supervised learning and unsupervised learning techniques. More of this is in the term paper also. Unsupervised learning algorithms have been used widely for house price prediction with a focus on regression models. However, unsupervised learning is very uncommon and limited in this field, though it can be implemented in some techniques such as clustering, where you group similar features that contribute towards house pricing in a class. But it's very limited in this field. Research gaps in the literature. These are some of the research gaps that I found. Limitations of supervised learning. It can't do everything. Inadequate feature engineering, where it's not that accurate, and the data that is actually being used in the end for predicting these house prices is not accurate. Limited representation of key factors and lack of data. There are also technical challenges that face existing machine learning techniques for house price prediction. For example, it can be difficult to effectively handle missing data, noisy data, outliers in input features, etc. The main contribution of the term paper could be to address one or more of these research gaps that I found while carrying out the literature review. It could involve developing and evaluating new machine learning algorithms or techniques for house price prediction, or improving existing algorithms by incorporating new features or addressing limitations in the data or model architecture. Methodology. The AI process for this step most involved 5 steps. Data collection, this was like getting the data set, data pre-processing, this is data cleaning and exploratory analysis. Feature engineering, I explained it earlier. Model training, using training data sets, and model evaluation, using the evaluation metrics. The data set used for this project was obtained from Kaggle. It was a house price prediction competition dataset that was available for everyone to use. It was split into two files, a training set and a test set. And the target variable to predict is sale price of the property that was expressed in dollars. When selecting a dataset for this AI project, there are 4 main features that were considered. The 4 main features that I considered when getting this dataset ahead of all the others. I even changed from one of my previous ones, Japan real estate prices, to this one because of these factors. So the relevance, quality, size, and availability. Data preparation and exploratory analysis. It is a crucial step in any machine learning project, as the quality of data significantly affects the performance of the model. We performed 5 steps in preparing and cleaning the data. That's handling missing values, outlier detection, data normalization and standardization, feature engineering, and data splitting. And to the models I implemented when carrying out this project there were only 6: linear regression, ridge regression, lasso regression, random forest, support vector machine, and gradient boosting. Though this gradient boosting was through XGBoost regressor. I also applied AI accountability by ensuring that the models I selected and implemented were transparent, fair, and unbiased in their predictions. I made sure that the data used for training the models was processed and collected ethically, and the privacy of individuals was protected. This is why I used the big dataset, the one that was provided by Kaggle. Because I used regression for this house price predictor project, I had to use different evaluation metrics from the norm. Those were squared error, mean absolute error, root mean squared error, and R squared to assess the performance of these models. I couldn't use accuracy, recall, precision, or reference score due to continuous data and multi-data. They cannot be mixed. And ended up using the comma. And in the end, the final evaluation metric I used was root mean squared error. That with the lowest error was selected to be used. I created a graph and it proved that XGBoost regressor was the model with the lowest root mean squared error. In conclusion, this AI project was aimed at solving a real-life problem using this aim as a Iowa housing dataset that I got off Kaggle. I prepared, cleaned, and transformed the data into a suitable form for modeling. Several models were selected and implemented, and the best model was chosen based off of the previous evaluation metrics. The results showed us that there is still room for improvement. However, the project for now, I believe, is suitable. To ensure AI accountability, an explainable AI technique was selected and applied to the results as discussed in the term paper. Yes. In terms of future work, there are several ways to further improve the results of this AI project. This includes incorporating additional data sources, using a larger data set, and experimenting with different explainable techniques and algorithms that can be implemented in this project. Overall, it was a valuable experience that showed the power of AI in solving real-life problems and the importance of ensuring AI accountability through explainable AI techniques. In the PowerPoint slides, there are also the links to the final source code, which is stored in my Google Drive folder and the dataset. Thank you for watching this video.